Today we are taping a video on factoring, and this is factoring a quadratic in the form of ax squared plus bx plus c. So the one thing that you learned in Algebra 1 and in your other previous maths, you always start by factoring out a GCF if there is one, a greatest common factor. And that is a greatest common factor to every single term that is in your quadratic. And the next thing is that you ask yourself what two factors of a times c can add up to equal b. Now, I'm going to go through and I'm going to do one, and then I'm going to use a couple of different strategies to help you. And you can pick whichever one works for you. So here's our example, and we have n squared minus 9n plus 20. So I ask myself the questions, what factors of a times c? So a times c is 1 times 20. So it's equal to 20. So what factors of 20 can add up to be negative 9? So I list my factors of 20. I have 1 and 20, 4 and 5, 2 and 10. So then I have to figure out which combinations, when I multiply them together, is equal to positive 20. So our choices are positive 1 times positive 20, or negative 1 times negative 20, positive 4 times positive 5, or negative 4 times negative 5. Positive 2 times positive 10, or negative 2 times negative 10, because a negative times a negative is a positive. So in this situation, I think of, okay, I have the two choices of 4 and 5. And when looking at that, I can go ahead and I can say, okay, they both need to be negative because they add up to be negative 9. And then if I multiply negative 4 times negative 5, it's equal to 20. And if I add negative 4 and negative 5, it's equal to 9. So I kind of checked myself, and then you can always check by FOILing. I am adding on to my previous video, so there's also a method that you can use that is called the XFactor that helps you with factoring also. And remember, it is when we're factoring quadratics, ax squared plus bx plus c. And my first step is still to factor out a GCF if at all possible. It makes your life so much easier. CF if possible. So let's work on number 3 from our work that we did today. And number 3 looks like 3x cubed plus 15x squared minus 42x. So I look and I see, okay, it has a common factor. Every single term I could factor out a 3, and I also could factor out an x. And I kind of look to see if I can get it into this form, and if I factor out a 3x, that means I'm dividing each term by 3x. I put that there sometimes to help me remember what I'm doing, and it becomes x squared plus 5x minus 14. So now I'm in the form of ax squared plus bx plus c. So the x factor is where I draw an x, and the top part of my x, I'm going to end up putting a times c, and I always use the stuff that's inside the parentheses. I leave the factored 3x to the outside, because then my answer is going to look something like this when I'm done. And then b goes in this spot. So a times c, 1 times negative 14 is negative 14, and then b is 5. So now over here, I list factors of negative 14. Now it has to equal negative 14, so one of the factors at least has to be a negative. So in this case, I can have 1 times 14, negative 14, or I can have negative 1 times positive 14, and both of those equal negative 14. And then I can have 2 times negative 7, or I can have negative 2 times positive 7. Okay? Now, I find which factors sum would be 5. Which factors sum would equal b, or in our case, 5. So in this case, I have to say, okay, when I add those together, it's negative 13. When I add these together, it's positive 13. When I add this together, it's negative 5. When I add this together, it's positive 5. Use your calculator. Add the two factors together. So it ends up being this. And so I put this negative 2 and positive 7, and that's what you're leaving. So these are my factors that multiply together to be negative 14, add up to be 5. So these two are my answers that I put with my x's in my parentheses. So x minus 2 and then x plus 7. And it works almost every time. The only time it doesn't work and you have to do an extra step is if my leading coefficient or my a value was not 1. And if a is not 1, which we won't have any right now like that, but if a is not 1, then you would have to do one extra step. So let's look at number 5. And number 5 is 6n squared plus 6n minus 12. So in this case, I'm going to factor out a GCF. 6n squared plus n minus 2. Okay, divided each of my terms by 6. And then I use my x factor, a times c, b. And so a times c is negative 2 and b is 1. Remember, there is a 1 there. So I list my factors, negative 2 times 1, positive 2 times negative 1. And I see which ones add up. The sum is equal to 1, and that's this one. So I place these to negative 1, and that becomes my factors. N plus 2 times n minus 1. So practice makes perfect with this. Keep practicing it. See what you got. Now, if I was going to do a lesson on a little bit more of the stuff that we're talking about, when we get to the section of 21 through 28, this is just completing the square, and this is exactly what we did yesterday in class, except it's doesn't have to do with the circle. So from yesterday's class, we know that the c term is b divided by 2 squared. Well, we talked about today, the same thing as dividing by 2 is multiplying by a half. So in this case, I can say this is b times a half and square it. And the reason I did that is because b is a fraction. So 5/4 times 1/2, and then I square it, is equal to 5/8, and square it is 25/64. So c here is 25/64. And you do each of them the exact same way. When you get down to 29, through the rest of them, those are just writing the equation of a circle in standard form. And there is a lesson that's already taped on this from yesterday, and it's called Completing the Square with Circle Equations.